everyone. Today we're going to cover section 2.2, and this one's going to cover physical properties. To start off with, if you had two pitchers, one full of ice water and the other with lemonade, on a picnic table, and I asked you which one has the lemonade and which one has the water, you're going to look at me like I'm dumb and say, oh, that's easy. Lemonade's yellow, and if you would taste it, it has a tart taste or it could have sweet, depending on how much sugar you add. That yellow color and that tart taste that you're describing to lemonade are called its properties. In contrast, you might say that water is clear and there's not really a sweet or tart taste to water. Properties are anything you observe about a sample of matter, and usually these are taken in with your senses. For example, you can see something's color, its smell. You can see if something weighs a lot or maybe it doesn't weigh very much. Is something hot versus cold? Anything that you can use to describe a sample of matter is its properties. Today we're going to learn about a specific type of property called a physical property. And this is going to be contrast to what we'll talk about later in the week, which is a chemical property. So a physical property is defined as anything that you can observe with your senses or measure it. So for example, you might measure something's length or width or its mass. But when you do these two things, it does not change the composition. So the key word here is without changing the composition. And remember, the composition is what it is made up of. So there are a lot of different physical properties. The several that we're going to talk about today are viscosity, conductivity, malleability, hardness, melting and boiling point, and density. There are a lot of other examples out there as well, such as color, smell, mass, volume, texture of things, etc. So the first one we're going to talk about is viscosity, which is defined as the tendency of a liquid to keep from flowing. So it doesn't flow very well. A good example of something that has a high viscosity or a viscous fluid is going to be things that are very thick, like corn syrup or syrup you might put on your pancakes or honey. If you've ever tipped a bottle upside down, these come out of the bottle very slowly because they don't want to flow. Thin liquids, this is things like water and vinegar, these have a low viscosity, which means if you try to pour them out of a cup, they're going to come out pretty quickly because they're going to want to flow and move. The next one we're going to talk about is conductivity. This is defined as the material's ability to allow heat to flow. So things that are considered to be highly conductive are called conductors, and most of the times this has to do with metals. So metals are things like copper or iron or steel, even things like tin or aluminum. All of these are metals. Now, good conductors of heat are also usually good conductors of, and the key word here is electricity. So I kind of covered that up, so let's kind of put it over here, of electricity. The next one we're going to talk about is malleability. This is the ability of you taking a hammer and hammering a solid, and it doesn't shatter or break. In other words, we can bend them without breaking. Most of often, these are going to be metals, such as gold or aluminum and silver, like I talked about in the last slide. An example of something that is not malleable is going to be something like an ice cube or glass. If you hit that with a hammer, both of those are going to break into small pieces. And whenever something is not malleable, we say that they are considered brittle. Hardness is the next one. This is defined as if one material can scratch another if it is harder than the other material. So to determine hardness, we have to scratch two things off of one another. The example that they use is a kitchen knife versus a copper baking sheet. A kitchen knife can scratch a copper sheet, and the reason for that is because the stainless steel that is the knife is harder than the copper in the copper sheets. The material used to sharpen the knife blade, on the other hand, has to be harder than the stainless steel in the knife in order to sharpen it. And fun fact, diamond is one of the hardest known materials. I ordered my husband in a ring, and one of the carrying instructions for it was do not let diamonds scratch it because of how hard diamonds are. The next two are melting and boiling point. Temperature is considered a physical property because you can measure or observe that something is hot and it doesn't change what it is. If you observe that you have hot water, it is still water. Now, there are two types of temperature changes, melting versus boiling point. Melting is when something goes from a solid to a liquid or it melts. An example of this is ice turning into liquid water. It's still H2O. Boiling point is when something goes from a liquid to a gas. So that's going to be something like water turning into steam or water vapor. If you remember correctly, melting and freezing, that's done at 0 degrees Celsius, and boiling is at 100 degrees Celsius. The last one is density. Now, density should sound familiar because we did talk about it in the measurement chapter. It is a ratio, and remember, ratio is division. So that means density is going to equal the ratio, division of mass of a substance to the volume of a substance. So if you know its mass and its volume, you can divide them to get density. Now, density can be used to test how pure something is. A good example of this is if you're given a coin. If you know that the coin is silver, you can figure out for sure if it's 100% silver or not. First, you would have to look up what is the density of silver, and you might look up saying it's 10.5 grams per centimeter cubed. Then you would take your coin and measure its density, and you might measure it to be 9.9 grams per centimeter cubed. Since these densities don't match up and they're kind of far off, we know that the silver coin is not 100% silver. There's something else in there. In fact, gold and silver jewelry is almost never just pure gold or pure silver because we add other elements in to make the ring or necklace stronger. So why do we care about learning about all these physical properties? Why are they useful? Well, there are three reasons why they're useful. First, they help us identify a material. So if we have something we don't know what it is, it allows us to figure out what it could be. Second, it helps us choose a material for a specific purpose. So if I'm trying to find a very soft, comfy chair, what material would I look for? And the last one is to separate substances in a mixture. This little sentence is not written in on your notes, so I would kind of make a little note inside your already pre-made notes. First, let's talk about how we use it to identify materials. Say we had two clear liquids, and we were not for sure which one was water. Well, we could test those liquids, but we have to first determine what we want to test about it. So we have to determine the properties to test. You may look at its color, maybe you're going to test its smell, maybe you'll test its density or boiling point. Any of those can test water. Then we need to actually perform these tests. So maybe on one, we might test the density and we might test the smell. Water doesn't really have a smell and its density is 1. So if you test an unknown, and it has a very strong smell and its density is 0.78. When we compare that to what we know about water, we know that there's no way my unknown could be water. So it's probably not good to drink. So again, decide what to test, do the test, and then compare them to what you know. The second reason we study physical properties is to be able to choose good materials for what we're trying to accomplish. So properties determine which materials we're using based on what their function is going to be. A good example that your book gives is shoelaces. So a couple properties that we want is we want them to be flexible because we bend shoelaces, we don't want them to break. We also want them to be durable. So we want them to be able to withstand repeated use or getting wet, getting hot, etc. So oftentimes people choose shoelaces made of nylon or leather. We wouldn't make it out of wood. The reason for that is because wood's very hard to bend without breaking. It's not flexible. That brings us into physical changes. Physical properties and physical changes usually get taught hand in hand because physical changes are just physical properties. These physical properties of a substance can change, but the substance in the material remains the same, or in other words, the composition doesn't change. For example, water is a liquid, and if I were to turn it into a gas, notice the state of matter changed, but this is considered a physical change because water as a liquid is H2O, and water as a gas is still H2O. This is physical. Now, during a physical change, the size of something may change or the shape, but it doesn't change what it's made up of. For example, you can melt butter in a pan, but it's still butter. You can crumple a piece of paper and change the shape, but it's still paper. Or you can slice a tomato and change the size into dices, it's still a tomato. So changes in state, like solid to liquid, when I melt things, is considered physical. Or change in size, cutting a piece of paper in half. That's considered physical because it's still paper. Now, some but not all physical changes can be reversed. Braiding hair is something that you can reverse, but cutting it, you can't put it back how it was, so that's irreversible or not reversed. And to round out this lesson, we're going to talk about the third reason why we study physical properties, and that is to separate mixtures. There are two major common ways to separate mixtures. The first one is filtration, and the second one is distillation. So with filtration is a process that separates things based on the size of their particles. So here is an example. Maybe I had a solid and a liquid over here. So let's just say this is sand and water. Usually you filter it through filter paper. Oftentimes, anything that is small is going to go down here in the beaker. So small things pass through to the bottom. But anything that's large and can't pass through the filter paper gets stuck up here. So you might see sand stuck in the filter paper and everything else flows through. This is an example of regular filtration in class with sand and water, but you do it in your everyday life. For example, if you use tea bags, you can separate hot tea from loose tea leaves by pouring them through a strainer or using a tea bag. People who make coffee have to buy coffee filters so the coffee grinds don't get into their drink that they're drinking in the morning. And then filter paper, such as in lab. Here's an example of students filtering or sifting through dirt. They have a contraption here, and there's a wire screen. Anything that is smaller than the holes in the wire screen can pass through to the bottom, but anything that's too big, like pottery, are trapped behind. And often, if you've heard of the gold rush, that's what they did. They were panning for gold. The second thing is distillation. This is defined as the process that separates substances in a solution based on their boiling points. So we know that water boils at 100 degrees Celsius, and let's say we had salt, this one is above 100 degrees Celsius. So say for example I had in this flask salt water and we wanted to separate it. Water boils at a lower temperature than salt, so we would boil the water and let it evaporate. Then we would take that gas and we would run it through some cool water to turn it back into a liquid and then keep it in this flask. So this is pure water, and then salt would be left behind. Chromatography is something that kids were talking about in class. You guys have done this with Miss Tom. It separates things in a mixture based on how fast they travel through another substance, such as paper, liquid, gas, or even thin layer. Most often, people have done paper chromatography, where you've worked with ink. We know ink is a mixture because if I were to draw a line on this paper and set it in a liquid, such as alcohol or water, you will see that the parts of this mixture will move up the paper and they will separate into the different parts that make it up. For example, this color is made up of green, red, and yellow. The last one is physical separation. So you can physically take tweezers, separate small from large objects. You can use a magnet to separate iron because magnetism is a physical property. You can magnetic iron and it doesn't change what iron is. And the last one is to decant or pour off something. So say you had two layers, a normal layer, and then this layer has a bunch of solid, you can just pour off this top liquid. And that's the end of today's lesson. If you have any questions, please do not hesitate to ask. And otherwise that, I hope you guys have a great day.